Alright, Logic fans, welcome to our second video on section 3.4. This is video 3.4b, and at the end of our last video, 3.4a, we introduced the rule of replacement exportation and explained it a little bit. Let's see it in action. Try to syntactically deduce this string right here from this string here, pause now. Okay, so nothing too surprising here, just one-step application, but you do have this not, and the key was to see that this whole thing here, not b, is actually the value of q, and so it gets rewritten this way. Let's try one more together. See if you can syntactically deduce this string from this string, pause now. Alright, so in this case, it's no big deal, but you're basically going the other direction. So you're going from this to this, so this situation here. And here you want to make sure that the not C is regarded as R, and basically you've got your A and B, then not C. So pretty straightforward, natural use of a rule, okay, in this case. Let's press on to our next one, which is our final rule for today, equivocation, and our final rule altogether. Okay, so this is all of them. We will have axioms, and we're going to practice combining all of them together and everything later, but let's just make sure that we understand the rules and how they're supposed to work before we get into all of that. So, in this case, equivocation, abbreviated Equiv, has 4 components, okay? But you really just want to break them up into groups of 2, because this one is just saying you can do this maneuver and you can do it the other direction. And this one's saying you can do this maneuver and you can do it the other direction. So let's go through these. Suppose you start with P tribar Q. Now notice, this is the only rule of syntax, the only rule we have whatsoever for tribar. Okay, the only rule of inference or replacement. This is it. Okay, so this is your one-stop shop for all things involving tribars. Now, basically, this is pretty easy to remember, because if you remember from our discussion of biconditionals from chapter 1, okay, what I said there is that a biconditional is really just 2 conditionals. Right, the left to right direction and the right to left direction. And so that's what you have here. If you have a biconditional, you can expand it to 2 conditionals. So this conditional and this conditional, and that's Equiv. Okay, and you can contract it from the 2 conditionals to a single biconditional. So you can go from this here to this, right? Pretty easy. Okay, so it's not nearly as bad as it might look at first glance. Now, the other thing you can do with Equiv is you can expand from the biconditional not to 2 conditionals, but to a disjunction, right? So remember, think about the truth table for biconditional, okay? A biconditional is true when P and Q have the same truth value. So either they're both true or they're both false. Otherwise, the biconditional is false. So if P is true and Q is false, or vice versa, okay, then the biconditional is false. That's exactly what you have going on here, okay? So either P and Q are both true, or P and Q are both false, okay? So that's an easy way to remember it. So you can also expand, instead of to 2 conditionals, to this form if you want, and you can contract from this form to this. So you can go from this expanded form to this. Now, since we're running out of space here, and I want to give us some examples to work with, I'm going to put this case over here just so you can see it all on one page, and just remember that it goes both directions. You can expand and contract here, you can expand and contract here. Let's look at an example. So let's play permissible or impermissible. Try these 2 cases. In both cases, allegedly Equiv has been used correctly. Has it been used correctly or not? Permissible or impermissible uses of Equiv. Pause now. Okay, hopefully you've had a chance to think this through for yourself, but this is absolutely permissible, right? So in this first case right here, what we have is an application of Equiv from this form to this expanded form, right? And that's perfectly okay. You can do that. It's just that you got to recognize here that not A is in fact the value of P, and so you get not A arrow B and B arrow P, right? Not A. And that's perfectly fine. So you get your left to right and your right to left direction, and that's perfectly permissible to do. Let's take a look at this case. What's going on here? Well, the person wants to expand in the other way, right? So they want to do it in this particular way, from this to the ands and the ors. So the way to think about this, right, is that if you had the A without the negation there, you would just expand it without this here, right? It would look like this. But since your P is now this thing, you're going to have the P working like this, okay? And so this is absolutely permissible. All right, so that's the way I would sort of think about this particular case, is just like this. Okay, let's try two more together. So here's two new ones: permissible or impermissible use of Equiv in each case. Pause now. Okay, hopefully you've had a chance to think this through, but we'll go ahead and do it together. And notice you've got A in this position and this position here and here, and so that works out well for going from this expanded form to this more contracted form, right? And then you've got the not B in both cases, which is good. You know, if this one had just been B by itself, that wouldn't work. Or if this one had been like this, it wouldn't work, okay? It's got to be the not B in both places, right? Because of, just look at your form, you got the Q here, okay? Now, let's go ahead and take a look at this particular instance, which is an instance of this form. So they're going to try to go from this expanded form to this contracted form. Now, let's see what we have here. We've got P and Q, and then we've got not P, which is correct, and not Q, and then you've got your P tribar Q, so this is permissible. This is absolutely okay, and that is done correctly. Pay close attention to how the negations worked. It's all because the A started with a not A, then you had not A. Do not do it like this. That wouldn't work, okay? It has to be like this, all right, for this particular case, given that you have the not A, all right? Okay, so I hope that clarifies what is intended by these rules and what their powers are. I want to try one of the homework exercises together so that you can see some of this. We've got a lot of rules now. Make sure you're using the cheat sheet card to keep them all straight and remind you of what rules are available to you. But to start solving some more sophisticated problems, all right? And this just takes practice. So let's do one together to finish off 3.4. Let's try this problem together, okay? And some of these are hard, okay? And this is why you need to be practicing them regularly. And we're going to be talking about strategies and problem-solving techniques, but really study the problems and the solutions given in the text, okay? And dedicate some time to it. And that's what's going to really help you increase your problem-solving ability, not just in logic, but generally. This is really good mental exercise. Okay, so in this case, we've got three premises and a conclusion, okay? And you're going to have to call upon all of the rules, so make sure you're looking at all of them, including the ones we did today. This one's hard, and I'm going to do a little bit of a walkthrough with us through it. So pause now, give it a try, and we'll do a bit of a walkthrough together. Okay, so we've got three premises, all right? And they're kind of interesting. And this up here, I like to put down what I'm trying to get to, all right? So I always have that to easily reference. Now, we've got a lot of stuff going on in the premises, and when I look at this, as when you look at this, I have no idea how to get to this from these premises. Like, it doesn't just occur to me automatically, even with all my experience. So what does occur to me? what occurs to me is I sort of look at, okay, I need to start manipulating things and see where I get. But one thing that I notice is that C seems to play a role in every premise. Okay, then I notice that I've got a C or not C. And this suggests possibly constructive dilemma. So check out your cheat sheet for constructive dilemma to see what I'm talking about right now. But basically you've got one thing or another thing. So if I had C implies something on a line and I had this other thing not C implies something, then I might be able to get something new, and it looks like I might be able to get that because I've already got C or not C, but I might be able to manipulate these into something of the form C implies something and not C implies something. So I'm going to try that as a strategy and see where it gets me, sort of a trial and error approach, okay? So here's your hint, all right? Can you take this line and turn it into C implies something? So you would have C on the left side all by itself, arrow, something. Pause now. Okay, so hopefully you're able to see that, hey, look, I can use trans to get C on the left side here, okay? And then I have to insert the negation, but then I can double negate this out. And now look, I've got C or not C, and I've also got C implies something. In order for constructive dilemma to work, I need not C to imply something. So I haven't used this premise yet. Can I isolate the C by itself and then maneuver it to the left side so that it's not C and it's implying something with the first premise? Pause now and give that a try. Okay, so just inspecting one, I can get C isolated by itself by exporting it, right? So I can get, if this thing implies that this thing implies this thing, then this thing and this thing together implies this thing. So what I've got here in 6 is that I've exported that first premise, and I've got A and B isolated here, then C and C's isolated. Then of course I can just trans that to get this. And so now I've got C or not C. I've got this thing, C implies something, and I've got this thing, not C, implies something. So what would constructive dilemma on 3, 5, and 7 yield? Pause now. Well, it yields this thing or this thing, right? Okay, so that's exactly what that looks like. Okay, and now if you take a look at things, right, in particular if you look at what you're trying to get to, this conclusion, you've got something very similar. So now it's a matter of using various rules of replacement to manipulate this sucker into looking exactly like this. So you're going to want to use com, and you're going to want to use, De Morgan's and all these kinds of things, okay, and Impl to get to this, okay? So go ahead and try manipulating this sucker until it looks exactly like this. Pause now. Okay, so a little bit of a hint. What I first did was I started with trying to basically say, okay, I'm going to manipulate this part of the disjunction to look exactly like this disjunction, and so I needed to move the B and the D, so I switched them over using trans, and I got this expression. Then I double negated it out, and now this whole left part looks exactly like this whole left part, okay? And so now I need to make the right part. So with that hint, pause and see if you can finish it from there. Okay, so here's another hint. I can't turn this directly into a conditional, but I can use De Morgan's to turn it into a disjunction, which can become a conditional. So now I've got this expression. I want to make it look like this. So take it from there. And okay, I want to get the B over in this position, right? Because that's what I'm trying to get to. And then I use Impl to finish it off, and boom, there it is, okay? And these are the kinds of techniques that we're going to be using and discussing a lot, but really make sure you're getting that practice in. That's what's going to get you this down, and trust me, you will build these skills quickly. Catch you on the next videos, guys.